morning to all. Today we have to discuss about heat of formation or enthalpy of formation. What is the heat of formation or enthalpy of the formation? It is the 1 mole of substance formed by elements in their standard or stable form. Okay, so you should remember enthalpy of formation, always 1 mole of the substance formed, always 1 mole of the substance formed. Okay, so heat of formation means 1 mole of the substance formed by elements in their stable or standard state. Stable or standard state. Okay, 1 mole of the substance only formed. Okay, already what are the stable and standard states? Last class we discussed. For carbon, always graphite, stable and standard state. Sulfur, rhombic. H2, Br2, N2, O2, gas form. Like that. Water, liquid. That's why in the stable states only formation. Okay, that's why. For example, carbon is there. Carbon plus O2 for suppose. Right here, graphite. Otherwise, this is combustion reaction. Another example we take it. Carbon, graphite plus 2H2 gas gives rise CH4. Here, enthalpy of formation equal to x kilojoules per mole minus x kilojoules per mole. Graphite. For example, C, diamond plus 2H2 gas. Here, this is not enthalpy of formation because graphite only formation, stable product. Diamond cannot formation. That's why in enthalpy of formation, the elements should be formation to 1 mole of the substance in their stable and standard state. Here, carbon in the form of graphite only formation. Carbon in the form of diamond, it cannot formation. So, formation but instability. That's why enthalpy of formation means 1 mole of the substance formed by elements in their stable and standard state. Okay, their stable states only you should take. Here graphite only formation, diamond cannot formation. Okay now. Then enthalpy of formation represents by del HF. F means formation, already know. Del H means enthalpy change. So this enthalpy of formation may be exothermic or endothermic. Maybe exothermic or endothermic. So maximum reaction, more than 85 to 90% reactions belongs to exothermic. Some few reactions belongs to endothermic. That's why while explanation of heat of formation or enthalpy formation, okay, we can explain it can exist as both exothermic and endothermic reaction. Some reactions exothermic, some few reactions exist in endothermic reaction part. That's why heat of formation may be exothermic or endothermic. Next, standard heat of formation. Standard heat of formation. Standard heat of formation equal to del HF naught. Del HF naught. So what is standard conditions? 1 atmosphere pressure, 1 atmosphere pressure, comma, 25 centigrade or 298 Kelvin temperature. 298 Kelvin temperature. This is the standard heat of formation. If they didn't given any conditions, means generally enthalpy of formation we consider as a standard heat of formation, del HF naught. If they didn't given any conditions, we considered as a heat of formation is standard heat of formation. Next, for chemical reaction, any chemical reaction, A plus B gives us C plus D. Okay, this is the one reaction. So enthalpy of formation equal to change in enthalpy of formation equal to enthalpy of formation of products, enthalpy of formation of products minus enthalpy of formation of reactants. That means in any chemical reaction, enthalpy of formation equal to products minus reactant. So any chemical reaction, enthalpy of formation equal to products minus reactant. Okay, here del HF equal to enthalpy of formation of, otherwise C, enthalpy of formation products is C, C plus D minus A plus B. Okay, enthalpy of formation products minus enthalpy of formation of reactant. So directly you can calculate. This is required order. So enthalpy of formation equal to enthalpy of formation of products minus enthalpy of formation of reactant. Okay. Next one. Heat of combustion. Heat of combustion. Heat of combustion or enthalpy of combustion. Enthalpy of combustion. Enthalpy of combustion. Heat of combustion or enthalpy of combustion. Okay, what is the heat of combustion or enthalpy of combustion? Means 1 mole of the substance, 1 mole of the substance undergoing to burning in presence of excess of oxygen. In presence of excess of oxygen. So heat of combustion means 1 mole of the substance undergoing to burning in presence of excess of oxygen. So 1 mole of the substance undergoing to burn burning undergoing to burn in presence of excess of oxygen. Excess of oxygen. So oxidized. Okay, examples. Carbon should be graphite amma. Carbon in the form of graphite only undergoing to heat of the reaction, because graphite form only stable and standard state. So carbon plus oxygen gas gives rise CO2 gas. So enthalpy of combustion equal to negative. Next, sulfur, rhombic. Always sulfur going in the form of rhombic. Plus oxygen gives rise sulfur dioxide gas. Enthalpy of combustion equal to negative. Like that. So 1 mole of the substance only, conformly. Only 1 mole of the substance. 2 moles, 3 moles giving means wrong answer. You don't count oxygen. You do not consider oxygen. 1 mole of the substance only. Oxygen excess. How much oxygen required? You do not consider. So you consider only 1 mole of the substance. Okay. So 1 mole of the substance undergoing to what? In presence of excess of oxygen. Always 1 mole only. So listen, heat of combustion is always exothermic, because combustion means burning. Burning means always heat energy released or heat energy evolved. That's why heat of combustion always exothermic. It always exothermic. Always exothermic. Okay now. Heat of combustion always exothermic. Next, standard heat of combustion means standard heat of combustion. Standard heat of combustion means del H naught C. This is standard heat of combustion. That means 298 Kelvin temperature, 1 atmosphere pressure. 1 atmosphere pressure. If they didn't given any conditions, so always enthalpy of combustion we consider as a standard enthalpy of combustion or standard heat of combustion. Okay, next one very important. For chemical reaction, for chemical reaction A plus B gives rise for suppose C plus D. Enthalpy of combustion equal to always reactant minus product. Okay, total 6 to 7 heat of reaction is there. Among that, combustion bond energy only reactant minus product. Remaining formation, dissolution and hydration, heat transformation, heat atomization, heat neutralization, everything product minus reactant. So heat of combustion, bond dissociation energy only, reactant minus product. So you should remember about this one. So heat of combustion, if we apply to chemical reaction, heat of combustion equal to reactant minus product. Okay. So reactant minus product. This is very, very important. Then if we observe differences between enthalpy of formation and enthalpy of combustion, See, between differences enthalpy of formation and enthalpy of convection. Enthalpy of formation may be exothermic or endothermic. Maximum reactions exothermic, few reactions endothermic. Enthalpy of convection always 100% reactions exothermic, always exothermic. Okay, this is the first one. Next, very important one, another one. In enthalpy of formation, 1 mole of the substance formed. In enthalpy of formation, 1 mole of the substance formed from the standard stable elements. Okay, that's why here 1 mole of the substance, 1 mole of the substance formed, 1 mole of the substance formed. Here 1 mole of the substance undergoing to combustion or burning. Here 1 mole of the substance undergoing to combustion. So here 1 mole of the substance undergo to combustion, undergo to burning. Okay, that means in combustion reaction 1 mole always left side, in formation reaction 1 mole always right side, product right side now. So combustion reactant left side. That's why here 1 mole of the substance formed, here 1 mole of the substance should be burning. Oxygen, combustion oxygen do not consider. Okay, next another one. For a chemical reaction, enthalpy of formation equal to enthalpy of formation products minus enthalpy of formation reactants. Enthalpy of formation products minus enthalpy of formation reactants. Here for a chemical reaction, enthalpy of convection equal to enthalpy of convection of reactant minus enthalpy of convection of product. Enthalpy of convection of reactant minus enthalpy of convection of product. So reverse sum. Enthalpy of formation product minus reactant. Convection reactant minus product. Okay. This is differences between enthalpy of formation and convection. Right. Next, for example, one problem. Just enthalpy of formation of to find out enthalpy of formation of C2H6. To find out enthalpy of formation of C2H6. If enthalpy of convection of C2H6 equal to minus X, you kilojoules per mole. And convention of or formation and formation of carbon dioxide and this is gas, carbon dioxide gas, water, liquid, carbon dioxide and liquid are minus y kilojoules per mole and minus z kilojoules per mole. This is data. So like that simple problems come on. What should you find out? To find out enthalpy of formation of C2H6. So what should you find out? That compound formation reaction you have to prepare. Okay, you have to prepare C2H6. Formation of C2H6 you have to prepare, because we find out enthalpy of formation of C2H6 only. That's why 2C plus 3H2 gives rise C2H6. This is the enthalpy of formation of C2H6. So here enthalpy of formation equal to how much? Next, enthalpy of combustion of C2H6 they given. So C2H6 undergoing to combustion, while preparing you do like that. Two carbons means 2 CO2 formation. Carbon always formation CO2 or sometimes CO. 2 CO2, 6 hydrogens is there now. 6 hydrogens means 3 H2O. Here 4 plus 3, 7 oxygens is there. That means 7 by 2 O2. Okay, equal to how much they given? Del H equal to minus x kilojoules per mole they given. Next, formation of carbon dioxide and water they given. Right. So now carbon dioxide. What I say, graphite only. Carbon, graphite plus O2 gas. Formation of CO2 gas. Equal to how much they given? Minus y kilojoules mole they given. Minus y. Next, water. Formation of water. H2 plus H2 plus half O2 gases only. H2O liquid equal to minus inside kilojoules per mole they given. Okay, this is the data. So in NEET exam not needed to write data ma. In mind only you are assuming, but first time now for your understanding I write every data. In exam in mind only assuming, no problem. Yet this is the main reaction. What should we have to find out? Enthalpy of formation of ethane we have to find out, C2H6. For C2H6 formation, this is the main reaction. We consider as a enthalpy of formation of C2H6 is the main reaction, because we have to find out that only now. Enthalpy of formation only we have to find out. That's why every reaction balanced to main reaction. This one leave that, combustion leave that. Here main reaction 2 carbons is there. Here only 1 carbon is there. In carbon dioxide formation only 1 carbon. In main reaction 2 carbons is there. That's why here into 2. Here main reaction 3 hydrogens is there. Here only water formation 1 hydrogen is there. That's why for balancing into 3. Next one always formation opposite to the convention. So this is the enthalpy of formation reaction. This is the enthalpy of combustion reaction. Always formation and combustion reactions one to another opposite. Okay, first reaction and the second, this one. Formation. This is formation reaction. This is combustion reaction. Formation and combustion always one to another opposite. Okay, that's why here now enthalpy of formation of ethane equal to del HF equal to enthalpy of formation of ethane. Here enthalpy of formation of ethane equal to, this is equation 1 you are assuming over, this is equation 2, equation 3. Okay, equation 3 plus equation 2, then combustion reaction always opposite to the formation reaction. So here when you take combustion reaction, minus sign take, that means minus 1. Understand now? Minus first equation, because why I used here minus sign means combustion reaction opposite to the formation reaction. Okay, these two has to take up, these two, but combustion reaction opposite to the formation, that's why I took a minus 1. Now third one, here 3 into third one, 3 into minus z plus minus z plus 2 into this one, 2 into minus 5 minus 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 of x, minus of x. Okay, equal to answer. Like that. So exam values given, for your understanding I am taking like that. For your understanding, in exam automatically they given values. Okay, now this is about the enthalpy of combustion and formation problems model. Okay, now next another one problem we have to take. Same model, we have to take another model. So try understand to find out enthalpy of formation of C6H6 benzene. Enthalpy of formation of C6H6 benzene. Okay, if enthalpy of combustion of benzene is minus 1525, roughly I take not exact value, just I took for your understanding near value. Okay, near value I took minus 1525 kilojoules per mole, and enthalpy of formation of carbon dioxide and water are minus 393.5 and minus 285. Approximately near value I took them, just near values. Minus 285 kilojoules per mole. For problem, you understand? Just I took near values. Minus 285 kilojoules per mole. Right. This is the problem. Try understand. Here, what what should we have to find out? To find out enthalpy of formation of benzene. So then what we doing here, we should prepare benzene formation reaction. We have to prepare benzene formation reaction. So 6C plus 3H2 gives rise C6H6. C6H6. This is the formation of benzene. We have to find out enthalpy of formation of benzene. Now, one by one reactions we only prepare. Sometimes in exam they only given a mark. In exam sometimes they only given. Sometimes they doesn't given. Enthalpy of convention of benzene. C6H6 convention. 6 carbons is there na, 6 CO2 plus 6 hydrogens na, 3H2O, 12 plus 15 oxygens na, that's why 15 by 2 O2. 15 by 2 O2. How much value they given amma? Enthalpy of convention equal to minus 1525 kilojoules per mole they given. Next carbon dioxide formation. Carbon graphite plus half O2 CO2. How much value they given? Minus LH equal to minus 393.5 they given. Next we have to find out water formation. We have to find out water formation. H2 plus half O2 H2O. H2 plus half O2 H2O. Enthalpy of convention equal to minus 285 kilojoules per mole they given. So this is the data. Then here, this is the main reaction. Always we have to consider main reaction. This is the main reaction. Main reaction comparison with sub reactions. Main reaction comparison with another reactions. Okay, convention reaction leave that amma. This both are one to another opposite. Formation reaction, convention reaction, both are opposite. This one leave that. For these two reactions, you have to do balancing. For these two reactions, you have to do balancing. Okay, according to main reaction. For these two reactions, you have to balance according to main reaction. Main reaction, how many carbons is there? 6 carbons. Here only 1 carbon. That's why into 6. Main reaction, how many H2 is there? How many hydrogens? 3 H2. Here only 1 H2. That's why into 3. Now balancing completed. Then convention reaction opposite to the formation reaction. Already we know. Convention reaction opposite to the formation reaction. Now enthalpy of formation of benzene. Enthalpy of formation of benzene or CCH6 equal to, we assuming this is equation 1, this is equation 2, this is equation 3. Equation 3 plus equation 2. Already I explained. Convention reaction always opposite to the formation reaction. Convention reaction always opposite to the formation reaction. That's why here minus 1. Okay now. This is now the substitute values. Minus 285 into 3 plus second equation minus 393.5 discussion time, while doubt clarification, doubt discussion time, we have to practice 6 to 7 problems. Okay now, so we have to solve 6 to 7 problems. You can